two vectors and I want to do some statistics and some algorithmic concept. So first of all, let's understand correlation. So when somebody says correlation, what comes in your mind? What is correlation means?
So if X goes up, increases, then Y also increases.
That's one. What about other?
Relationship between two variables.
So relationship between two variables. So first, what form means, and if one goes up, that's a vector. Other vector also goes up. That's one relationship. This is called positive relationship.
So there is negative as well. So if X goes up, the Y goes down.
Very good. And that's a negative relationship, right? So here completely opposite, right? Now this relationship, if I have like this flat line, or if you are this, then there is no relationship. There is no relationship. So now question remain. If I want to do some kind of predictions, allow me 10 minutes. I want to show you something important before we close because it's very close connection. So anytime you want to do any prediction, forecasting, your first step is the correlation. Do I have a correlation? Correlation means, is this variable has some relation? Example, if I study hard, I study number of hours, my grade will go up. So more study I do, grade goes up. So there is a definite relationship. But let's say number of books I have and grade goes up may not be the relationship. So we need to first identify these two vector has relationship, has or not. So correlationship, if it gives me number which is close to 95.95, close to 0.95, it can be positive or negative. But if it give me 0.95, then I have a strong relationship. If it is 0.8 to 0.95, then there is a relationship, but it's a weak relationship. 0.8 below, normally we call almost no relationship. Because ideally, if it is 0.95, then you can start thinking about forecasting. But if it is not, mostly you will be having error. So how do we do that correlation quickly? So let's work together. So I have a vector. I'm going to put 3 value, 1, 2, 3, 4 value. Let's do 4 value. And I have B vector. Please pay attention. And I'll say 10, 20, 30, and 40. You can see crystal clear that there is a relationship. Means if one C is 1, this is 10. If C is 2, this is 20. So definitely there is a relationship. Okay. I want to know, is this two variable has relationship? Means one is going one like that up, other is going 10 slab up, right? It is going up 10 slab, but it is going up. So it's a very nice relationship we have. I'm just putting perspective. So how do I prove that these two vector has some relationship? Very simple. Just use COR and put both vector, and right away you see it gives me relationship 1. What is 1 means? What is 1 means?
It's a strong relationship.
It means perfect relationship. Strong, perfect relation. What is perfect means? Perfect means, if, listen carefully, if I know the value of this vector, I can tell you what will be the value of this vector. Guaranteed 100%. Make sense? Why? Because correlationship is one means perfect. That is called this thing. When it is perfect relationship, you will have a 45-degree angle. It means if I draw a line from here, I know exactly what would be the value here. And if I draw a line from here, I know exactly what will be the value. There won't be any error. There won't be any error. What is error means? If I have 0.97, it means there is a 3% error. If I have 0.95, then I have 5% error. In statistical world, only you can allow up to 5% error. After that, you cannot take a chance. So 1 is the perfect. But you see how easy to find the correlationship in R? Simple COR and put 2 vector. That's pretty much it. Make sense? Any questions so far?
So they have to be of equal number and in the same
Absolutely.
order, right?
Of course, because it's going to go through like this way. If it is not same order, you have to sort it, and because you are going first to first, because you're drawing graph basically. If it is here to here, this is the point. Here to here, because this is your X graph and this is your Y graph. So your X axis, Y axis, and you're trying to draw graph. If graph goes give you line, straight line, 45 degree, then there's a perfect relationship. Absolutely. Order matters and number of point matters, because you have to draw point XY, XY, XY. If you X and you don't have Y, then you have to filter out. You have to filter out. Good. So far, so good. Okay. Now, please understand, correlationship and regression also goes hand to hand. Regression goes to hand to hand. So correlation and regression goes hand to hand. So you say, what is regression? So correlation shows there is a relationship. Correlation shows there is a relationship. And regression shows how strong it is. How strong it is. Regression has a formula. Correlation doesn't have formula. Correlations can give you 0 to 1. That's it. It doesn't give you anything, but regression has a formula. So let's understand, please. Very important. It takes 5 minutes. If you have two vector, let's assume for our case A and B. If I prove that there is a relationship, then I will go for graph. This is A axis and this is the B axis. And whatever point you have here, let's say example here 2 and here let's say 2. So I'll say 2, 2 point here. Let's say here 3, 3 point here. 4, 4 point here. Means 4 here, 4. And if I draw a line, it goes like that. So this point which I see is like a both vector values. If I draw a line and if lines are almost 45 degree and line goes from origin, it means you have 0 error. Why? So the regression formula is y equal to mx plus c. Mx plus c. Y equal to mx plus c, where m is nothing but slope. M is nothing but slope and c is nothing but intercept. C is nothing but intercept. You say, what is this? I don't understand anything. Explain, no problem. So what does it mean? If my line doesn't go from 0, but it goes like somewhere here, then this distance between this point to this point, distance between this point to this point is called C. C is intercept. So you're intercepting. That's your C. The more the distance, more the error. So that's your error. Now, the line which you have here, what's the slope of that line? So if I draw a line like this, right? What's the slope of that line? If that slope is not a 45 degree, that's M is the slope. If I have that slope, I can create this value formula because C I can calculate. I can calculate C, M I can calculate. Then if somebody say, what if I have this value, let's say 7. If the 7 is the new value, what would be the value of Y? And that is called prediction. So if I have a correlation stronger between 0.95 to 1, if correlationship is stronger, it means I'll go for regression. And if I go for regression, if I get a formula Y equal to mx plus c, and if regression can give me this value m and c, then I can add together and I can predict value of y using value of x. It's easily. Now m, c, everything R will give me. I only use 2 vector. R will calculate m, R will calculate c, and R will help me to predict. And that is what I'm going to show you. Only I can predict correctly if there is a correlation, and that is also strong correlation. If there is zero error, then y equal to mx. It's a perfect relationship. But most likely you will never get perfect relationship. So you always will have error C. Good news, R will give us M and R will give us M. They will give you both. And if you put the new value means the value does not have in a vector. This using this value, you calculate M and you calculate C using available vector. And for new value, you have to predict. And for new value, you're going to predict. And that's what I'm going to show you. Question. Good. So let's do it. First, I'll explain on the screen so you can understand. Correlations we just covered. And regression. Yes. Okay. So let's understand this so it's easier. I have two vector, x vector, y vector. So I'm going to draw the value like this. X vector, y vector. So x is 151 and y is 60. So 151, y is 63. I'm going to draw point. Okay. I'm going to ask first correlation. I'm going to put correlationship x and y, and you will see that. Then I'm using LM. LM stands for linear model. Linear model. Linear model, nothing but linear regression. Linear regression. Now y tilde. This is a tilde, which is in your keyboard. In your keyboard, there is a switch called tab. On top of that tab, there is a switch called tilde. There is a special symbol, tilde. So it's a y versus x. Y versus x. It's a tilde. So you are saying y-axis x, create a linear model. So as soon as you do that, it's going to give me M and C. Why M and C? Because regression is nothing but y equal to mx plus c. So this one will give us that value. Once I have that value, I say, hey, x is the driver, x is the driver, x is changing, and based on that change, I want to determine y. I want to determine y. So x is the driver. So here I'm going to create a small data frame for x and say for 170, what would be the value for y? You predict. Predict means forecast. So here you can see that these are predefined data. Using this data, we are creating linear model. Using this model, we are asking, use this model and use this value and tell me what would be the value of this result. So you can see 170. So you can see 170 should be closer to here. So if you are with, it should be somewhere here. And this model will tell us close to this value because 179 means this. So 170, how much it is? Let's play around and see. So why don't you guys copy this entire screen like this up to this? Copy this. Copy this. Copy this entire portion up to this. Ready? After you copy, go to RStudio and look for the plus sign here. Here, plus sign, and look for R script. Plus sign, and you get to say R script. It will give you scripting like this. Paste it here, Control V. Paste it here. Give me thumbs up if you are able to do so. Some reason I'm not able to see anyone thumbs up today.
Can you copy paste that whole regression on checkbox?
I want you to do, my forum. The reason, let me put in forum. Why? Because if something doesn't
Yeah,
come well,
I'm in a forum. Yeah.
then why don't you go
Yeah.
there? Because these are
Okay.
special characters. These are special character. If it is not working well, you will say, hey, it's not working. But forum through, we will be consistent. You and me both will be on same. That's why I keep using from forum. Because these are special character, it will be translated by WebEx and may not get a result which we want.
Tom, how did you get the R script?
Sorry?
How did you get the R scripting?
Okay. If you go to R Studio, you see on this, on the what do you call your toolbar, there is a tiny arrow is there. Yes or no? You click on tiny arrow and you get R script. Here, you click on tiny arrow
Okay.
and R script. Okay. I'm hoping everyone is slowly copying. This is R script is nothing but program. Because it's so many lines are there, I want to show you step by step. So what I'm going to do, I'm going to copy this, highlight this. And when I highlight this, you can see it's a blue color. After I highlight, I can click on run and only that portion will run. Okay, so I highlight and I run and you can see it created two vector, X and Y. So you highlight only that portion and you click on this run. Now I'm curious about correlationship. So I'm going to write here some space and say correlation. I'll say X comma Y, right? And now I highlight this line and I run it and I say it's 0.97. What do you guys think? Do we have relationship? Yes or no?
Yes.
Yes.
It is a good relationship, right? Now I'm going to highlight this line and see what is the M and C we are going to get. So you just highlight that and now run it. And you can see now it's going to get me relation. Let me print relation so it will be easier. So I'll say print relation. I'll print it. So that would be easier way to see M and C. So you can see it is calculating M and C. So right now, when I highlighted this and I also wrote this relationship. So you can see here X, underneath X, you see M, and underneath this intercept, you can see C. So basically what it says that it is a minus 38. It means the line is crossing this way. So it is touching at y-axis here. So this is your C. Minus means it's touching bottom. And this M, it's showing the slope. So the slope is 0.67 M. It doesn't matter. M is this and C is this, right? The formula is y equal to mx plus c. Now, I don't have to do formula. R gives me all interesting thing called predict. And then use this relationship inside with the data which you want to use for prediction. So let's repeat again. First, this vector, please pay attention. First, this vector, which is called training data. What we call training data. So using training data, which we started our today's journey, using training data, we found there is a correlationship. Answer was yes. Using training data, we use linear model and we created model, which we call training model. This is training data. Now we have model. This model gives me M and C for regression. Now I'm using actual data and I'm passing actual data to this model and say predict, forecast this. And that is the result which we are forecasting. So now we're going to highlight this and we're going to run it. And you can see that it is forecasting 76.229. So you can see here around 117, this is 179, 1, 2, 3. right? So you can see this is the fourth value. So in 179, it is 676. So it's closer, very close. So it is predicting very closely. You can see that 179, you can see. Now I'm curious, what about if I do 174? Should it come like close to this? Check it out. So I'm going to do 174 to check my model. So if I run that, if it come closer to 81, then yes, it is doing something right. So check it out. And it is right. It is coming closer to 81. So I'm more curious now. What about if I do 151? Will it come close to 63? I'm going to put it here 153, 51. And I run it. So now I can predict very close. Look at that. Very close. It means I have a model. The model I got through this training data, that model is really helping me. We call relationship is helping me to get the any value, and I can predict and I can generate result. Now I'm more curious. After generate result, can I draw a regression with a line and see how the data look like? No problem. For that, we are using plot. We are using Y and X. Color is blue. So we are saying color is blue. So you will see blue color. Main title means your title will be here, main title. AB line means this is the line A and B. AB means start and end. Linear model. So this linear model, using linear model, it will generate the line. The point will be 1.3 pixel difference, and we are using 16. X label means here what would be the label, and Y label, what should be the Y label here. So let's highlight and see that so you will understand what I'm talking about. So you can see nice graph you can see. And literally you can see that we don't have all data we don't have a, what you call connecting. So it's not a perfect relationship, but quite a good relationship we have. This graph which we draw, it is coming from plot. So plot is helping me to do graph. Y and X is nothing but these label you have. Blue means because of the blue, you say blue. So if you want to do red, you can do red and it will be red color. The heading which you see here, which is this heading, the AB line which you see here, it is coming from this line. This line is AB line. The CEX 1.3, which is the size of this, and PCH, which is nothing but 16, which is this circle. If you don't do PCH, let's example, if you do 9, there are different shapes are there. So if I do 9, and if I run this thing, and it lets me do red here, so you can see I can customize it here. So I can run now, and I will have different symbol. So you can customize it. There are a lot of things you will cover in graphics, but you can see entire linear regressions in few minutes. You have just vector, you got a correlationship, you created a model, now you predict. Now what about if I have data coming, I apply cleaning algorithm. After cleaning algorithm, I have clean vector. Using clean vector, I create a model. And then I ask, tell me what value you want to predict. So you can say, what about this? You pass it and you predict. And this is where most of the companies are able to do. This activity which you are doing is analytic activity. That's why sometimes your title is data analytics. Analytics because you are using very advanced algorithm, linear model, correlation. These are algorithm. You don't need to know in and out. R make it easy for you. You are using R, using algorithm. That's why your title is data analytics. Sometimes complexity will increase, but that will be data science or data scientist will help you. You will still use R. Program is not going to be hard. Neither you have to memorize it. You just need to know how it works. You need training data, apply to the linear model, create a model, and then predict the data. That's pretty much it. This is just nothing but plotting. Now, this one itself is a huge things in a job perspective, because in job perspective, you mostly use 3 words: regression, which you are doing right now, clustering, which we started, correlationship, classifications. These are the words you often use, and you need to know in and out about these words. And that's why I'm practically walking through drawing it. There are so many other examples we'll be using. Like example, we have, certain real data, like example, CS data or Chipotle data or traffic data. But ultimately the data will change only these two. This process will remain same for everything. It means if I bring Chipotle data, the data value will change, but otherwise everything will be same. Traffic will be same, everything. So this one, if you understand, you can reuse forever. Questions? Yes, Dave.
So as I'm understanding,
Mhm.
when you insert data into script,
Mhm.
you have to like insert in console. That's the only way we can get the
No,
result.
no, 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 no. There are many ways. Don't take it that.
Okay.
What you only is very challenging. Right now,
Okay.
you are just second step. In a real life, you can email, you can create a website, you can create a PDF file, but you are learning. So this is called debugging. Whenever you are doing something, you debug. You want to see, because you are developing, you don't know it's right or wrong. You don't know. So you are debugging. In a real life, you never use console, right? This is called authoring tool. Authoring tool means the script you are developing, you need to test it, right? It's working or not. So that's why you're using that. But in a real life, neither you use RStudio. You don't use RStudio. You use your script. And this script you run through Hadoop, you run through Spark, you run through some other program. You are not going to use RStudio. RStudio is authoring tool, just for development purpose only. The script which you do, this is called analytics. This can be run through Java. This can be run through Python. This can run through Hadoop. This can run through any other engines. There are many engines allow which it can run. Even Microsoft SQL, Microsoft SQL can run R. Power BI can run R. Tableau can run R. So that's what we are doing. We are developing R script, which is analytics. Makes sense?
Thank you.
Cluster. Okay, this is really, really cool exercise. I'm trying to simplify. So just to give idea, I had to go through a lot of readings, a lot of materials to create this simplification, because I can do cut and paste and make a lab super complex and I can do the result. But I know some of you do not have statistics background. I know some of you are beginning, starting, right? I need to make it so simple that you can literally visualize what we are doing. Okay. So this is the cluster exercise, which is one of the analytics algorithm. Whenever we say AI/ML, whenever somebody say AI/ML, there are 5 words normally they use. One is the correlation. I think you know very well. We talk about correlation. Second thing, they talk about linear regression. We talk about linear model last class. Third, they will talk about classifications. We did today with the graph, right? The survey and all classification. Fourth, they will talk about cluster. So cluster. So this is what cluster means. Grouping. Cluster means grouping. And fifth is a decision tree, which we'll cover next class. Why cluster is very powerful? Because cluster through, if I create a cluster, the next value, I can find out which cluster it belongs to. And if I know that next value belongs to this cluster, then this next value, which is going to follow some of the flavor of this cluster. So if this cluster is, let's say, person who is owning house, and this cluster is person is renting house, if you belongs to this, then we know that you must likely owning house. If you belongs to here, then we know you're renting house. Then you will say, but how do you know that? Step by step, just follow the flow, relax and enjoy. Just 10 minutes. I created simple, very simple exercise for you. I need a little bit. Yes, I'm ready. Tell me. So at least I know that you are ready, because this is very, very important. I don't want to miss out this. Are you guys ready?
Yes.
Okay, only one person said.
Ready.
Thank you. It's okay to say, guys. Remember, more you speak, more active you become. Anyway, there are there are law of learnings, right? One of the learning is active. So please understand, this is the product. In this product, I created product 1 to 12. So that's my one vector. Then each product, I have a quantity. I'm selling quantity. So I created quantity. You might have noticed that this quantity I created in a purposefully certain separation. Some quantity 1, 2, 3 like that, which is close to 1. And one quantity is 11, 10, 12, which is close to 10. I wanted two type of clusters. So that's why I kind of purposefully created a value like that. I can do any value and cluster will create. But I want you to understand that those value, which is 1, 2, 3, naturally they are lower cluster, and 10, 11, these are high cluster. Then price. I put the price randomly. So you can see some price are 50, close to 35, like that. So I have three type of price. One price is 10, close to 10. One is close to 20, and one is close to 40. I randomly did that. Now use this two vector. I'm going to create a cluster. So far, any question with this three vector?
No.
These are simple vector, if you ask me. You know this thing, you know this. This is just a data. Rather than going through a lot more files, I can read this data from files, right? I can create this. But rather than doing a lot of hard work, I created simple three vector. And using this vector, out of three vector, I use two vector and created data frame. And you are very comfortable that because we created price and quantity. So we created data frame. So far, so good. Now let me do it and you see that. So if I see here, please pay attention. Okay, it's very, very important. If you say in interview that you have done this, and if you walk through step by step, it will be quite impressive. So I'm going to run this thing. Let me put it DF here. And if I run this thing, I should see data frame. And I'm going to put it, I'm going to put it in a chat also. So you guys can run also. So please understand, we have three vectors. Out of three vector, both numeric vector I use here and created data frame. You can run it and you will see the similar answer as mine. Let me know if you are able to see that.
Yes, done.
Good.
Yes.
Now, please understand. Very simple, but very powerful. You can see this is a row number. And when I create a cluster, I need to know something business thing. This is generated by R. R generate this row number. I don't like that. So I'm going to write a row name as a product because this is a product 1, this is product 2, this is product 3. So when it create a cluster, I know what product it is. So it's a business. I want to know. So I'm going to write row names to this data frame. I don't like this 1, 2, 3. So for that, I am using a product name, which I have here. I'm using this product name and I'm saying that will be a now row name. So each product is one row. So let me show you so we'll understand it. So here, I'm going here and see right now when I'm doing DF, you can notice that you have 1, 2, 3, right? After this line, I'm saying row names. I'm saying row names DF prod. So I'm saying this prod. So instead of 1, it will be P1, P2, P3, P4. Why? Because that is the 12 product we have. So check it out. So now it will be more business language. So you can see now business. This is not a column. Please understand. This is not a column. This is the row name. Because when I create a cluster, I need to know business name. So that's a product. So I created row name. So far, so good. So I created row name. I'm going to give you. Everyone understand? Very important thing, because otherwise, how would I know what belongs to that cluster? 1, 2, 3, it's a random. It came from R. But here I know 1 and T 10 is a product 1, P2, 10 and 19. So if it is shuffling in a cluster, so I know which cluster this product belongs to. Good. Now I need to go and clean some data. In our case, we have all good data. So if you do any omit means any non-numeric data you can omit. Omit means remove, which we talked about last class. So then nothing, I don't have to do that because I have good data. Now this is very important, scaling. So please understand, when you do cluster, what happen is this vector you have, we have two vector, price and quantity. So what we are going to do, we are going to use a function called scale. More detail I have put in the forum, you can read about it. But what scale it does, it put a center point. And from center point, it try to find out how far this data is with the formula. So it put a center point and it find out how far the data is from the center point. So there is a formula I added here. Let me show you here. This is the scale. So scale, you can read about a little bit more. Scale is using formula. X means the vector first values, example 1, 3, 5, 7, 8. So this X is the first value. X bar is nothing but sum. So 1 plus 3, 4, 4 plus 5, 9, 9 plus 8, 17. So that's X bar. And then this is your standard deviation, which is nothing but SD of your vector. So in your case, price. So this SD allows you, so if you do middle point, remember we draw a normal distribution we talk about. So this is your middle point. From middle point, how far the data is. It will help us. If it is this side, it will do minus. If it is this side, it will do positive. You don't have to know in and out. I'm just explaining. So that will give us distance. It will give us distance. So right now, we are going to create a distance. So that we are going to say scale data frame. So it can create a distance. So let's do it. And we'll print that. So I'm going to put it here and I'll print that data frame. So you will see that it will use data frame and it will create a scale matrix. So you can see here, it created nice, you can see the values change. Did you notice that? So it's some values are positive and some are negative. So what happened? It found center point, and from center point, are you this side, which is negative? Are you this side, positive? Both things. So for both things, now it creates using this. So each item, it has up and down. Now I can use this scale and use a k-mean algorithm. K-mean is the person who came up with the algorithm. So that will create a centroid. And then it will ask, randomly it will create a centroid. And we can say how many times you're going to iterate. We can say n count, let's say 5. So 5 times it will ask, are you closer to this point or are you closer to this point? It will ask 5 times. And it will try to create a cluster. Based on this data, which one is closer here, it will remain in one cluster. Which one is closer to here, it will remain in this cluster. The magic happen in k-mean. K-mean is algorithm. K-mean already available in R. So we don't have to do much. We just need to pass scale. We need to say how many cluster we want and how many times we need to ask question. More question you ask, more accurate you become, because some point may be closer to this side and some may be closer to this side. If you keep asking, that point will go to this cluster or this, you will get a more accurate. So if you do iteration more time, then you get a more precise. But otherwise, in a 5 or 10, you will get the cluster. So let me show you how it works. So we are now using this scale. We are asking k-mean, that's algorithm, clustering algorithm, very popular algorithm. We are saying use DF. We are saying center 2. It means we are expecting 2 cluster. If I say 3, it will create a 3 cluster. And start 25 means it will keep asking 25 times questions to our data. Are you closer to here? Are you closer to here? And then it will find appropriate answers. And once you have it, you print that with the data, and you can see nice cluster. So check it out. Now I'm going to copy this. I'm going to give you, you will see that. And now look at that. You can also print that in a PDF file. Oops. Could not find. I need to install library. I forgot. I need to install. So this is good. Visualize the cluster, fviz cluster. Okay, so which library I have to use? I had, one second, I have used library. Let me see, I created yesterday only, so I should have library. Yes, FVS here, this is the product. Oh no, this sample, right? I think it's a plot, a PL or play, I think, plot. 1 second. Yeah, here you go. This is the library, sorry. Okay, let me install and I'll give you that. Sorry for that. I have to update the forum also for that. Yeah, almost there. I will install this library for you. Okay. Now I'm going to print it. You need to say ta-da. Look at that. Beautiful. So now see what happened. It created a cluster and it's a cluster 1, which has a P10, P11, P4, P6, P7, and P8. They belongs to one cluster. And you can see here, it's a close to -1. And this is close to 1. So remember the scale we were talking about here? So in scale, because I gave a 2, it created a cluster. So those which has a minus value, you can see the first 2 has a minus value. They kept it in one cluster. So you can see here, in this case, in my value here, you can see here P2, right? P2, and here you have P3. So let's see here what happening here. So this is like a P. Let's print the value. So it will be easier when we see that value. So here, why P2 and P9 are together? Let's assume. So P2, which is the second, and P9, which is total, I have 10. So 1, 2. Let's think about P2 and P3 because they are closer. So you can see here, they are like this. So 10, 19. As I noticed that this data, I kept one data which is one side, and the second data which we kept it on a 10 side. So definitely 10 and 11. So they both going this side, and they're higher value than the 10. So definitely move. If that theory is right, then what about 12 and 22? That should also move, which is correct. If that theory is right, then this one should also move, which is in our case. So that is also right. So you can see data is shifting based on the value, and cluster is working. So I'm going to give you right now entire thing. Why don't you run and give me thumbs up if you are able to, run it. See if you can run. Meantime, I'll update that thing. I'll update tomorrow for the thing, but check it out. Run your thing and see if you're able to generate the cluster. Simplest exercise I created where you don't need to know algorithm. You do not need to know all mathematics, and quickly you can create a cluster. If you want to create a 3 cluster, you just do 3 here and it will create a cluster for you. It will create a 3 cluster for you. It may not look good, but it will create a 3 cluster. See, it created 3 cluster, 1, 2, and 3. If you say, I want to create 4 cluster, you can do that. So it's up to you. It will try to create as many cluster possible. And when you have cluster, you have similarity. Good.